Okay, in this section, 110, we're looking at inverse functions. And so let's say that you've got two functions. And so that f of g of x equals x for every x in the domain, and the reverse of that is also true. G of f of x equals to x for every x in the domain of f. All right, so these are the conditions that would occur to say that function g is the inverse function of function f. All right, and so here's the notation. It looks like almost an f to the -1 power, but that's not a power. It's read as f inverse. So most of you are familiar with that notation. And so in order for a function to be an inverse, then f of f inverse of x should be equal to x, and f inverse of f of x should be equal to x. All right, and of course the domain of f must be equal to the range of f inverse, and the reverse. The range of f must be equal to the domain of f inverse. Basically, here's the deal. An inverse function undoes what the function does, right? So, like for example, square root and squared are inverse functions, right? So if I plug 5 into the squared function, I would get 25. Well, if I take what I got, 25, and plugged it into the square root function, I would get back to what I originally started with, 5. So that's why those two functions are inverses. They undo each other. Does that make sense? Okay, so that's kind of an example of what an inverse function would look like. So they undo each other, in other words. All right, so here's what the graphs of inverse functions would kind of look like. And so if you've got the point A comma B on the graph of f, then the point B comma A must lie on the graph of f inverse, and vice versa. All right, and so really if two functions are inverses, then the graphs will be reflections through the line y equals x, and that's kind of illustrated here. So that's kind of a graphical way that you can tell whether two functions are inverses or not. Are they reflections of each other through the line y equals x? Okay. Now, there's some conditions to look at to see if an inverse function even exists. So in order for an inverse function to even exist, the function that you're starting with must be 1-to-1. All right, so that means no two elements in the domain must correspond to the same element in the range. Okay, so here's the definition of 1-to-1. Okay, so a function f is 1-to-1 when for a and b in its domain, f of a equals f of b implies that a equals to b. So here's what we mean by 1-to-1. Like for example, if 1 is an element of the function and 1 goes to 2, right? Then 1 needs to be the only value in the domain that goes to 2. You can't have other values also going to 2. All right? Otherwise, it's not 1-to-1. And so the function f has an inverse, f inverse, if and only if the original function f is 1-to-1. All right, here's why. Let's say I have x's here. Let's say 2 and 4 are in the domain for x. And let's say 2 goes to 2 in the y, and 4 goes to 2 in the y. All right? So both of those values go to 2, let's say. All right, now, is this a function? Yes, every x goes to only one y. We don't have the same x going to two different y's. So this is a function. However, it's not 1-to-1 because 2 goes to 2, and another element of the domain also goes to 2. Therefore, it's not 1-to-1, right? Now, here's the reason why the function has to be 1-to-1 or it doesn't have an inverse. Remember, the inverse function undoes what the original function did, right? And so if I reverse it, if I start with 2 and try to do the inverse of it, then 2 goes to 2, and then if I'm doing it backwards, 2 goes to 2, and 2 goes to 4. So if I'm going backwards, it wouldn't even be a function. So that means there is no inverse function that exists for a function that's not originally 1-to-1. So in order for the inverse to exist, it's got to be 1-to-1, or else when you try to get the inverse of it, it's not even a function to begin with, because you would have the same x's going to two different y's when you reversed it. All right, so that's kind of the reason. All right, so what types of problems are we going to be faced with? We'll take a look at some examples here. Now, basically what they're going to be asking us to do is they're going to give us a function, and we have to find the inverse of that function. So here are the guidelines in order to find it. So first of all, use the horizontal line test to determine whether f even has an inverse function. So we got to decide, does it have an inverse first, right? So in the equation for f of x, replace f of x with y, interchange x and y, and then resolve the equation for y. Then you can replace that new y with f inverse in the new equation, and then you can verify that these are inverse functions of each other by showing that the domain is equal to the range of the other, and the range is equal to the domain of the other, and so on. All right? So how do we find the inverse of a function algebraically? So they're giving us a function, and they ask us to find the inverse. All right, well, the first thing that I want to do is replace the x and the y. Switch the x and the y. So here's my y, here's my x. I'm going to reverse them. I'm going to change y to x, and I'm going to change x to y. So I'm going to reverse it first. Okay? We probably should have made sure that we know that this is 1 to 1. And so remember, this is a linear shaped graph, and then so it would be things that fail the horizontal line test, like squared functions, they wouldn't be 1 to 1, and therefore wouldn't have an inverse. This one, however, does. So now that I've switched the x and the y, I need to resolve this thing for y. Well, how do I do it? First of all, I'm going to get rid of this fraction by multiplying both sides by 2. All right, so then I'll have 2x is equal to 5 minus 3y. So I want to resolve this thing for y, so I'll move the y to this side, the 2x to the other side. Whatever I move is going to change sign, so this is going to be 3y equals to 5 minus 2x, because remember the 2x is coming over and changing sign. Last thing I'll do is divide by 3 to both sides here, and then that will give me y equals 5 minus 2x over 3, and then that is your inverse function. Now if you wanted to, I know the guideline said to replace that with f inverse, so if you wanted to write that out as f inverse, then you could. All right? To completely finish it, that's probably what we should do. All right? Let's see, because that'll help us to get used to the notation as well. But just realize that that's f inverse, the inverse of f. All right? Okay, so find the inverse function of this. So once again, replace your x's with y's and your y with x, switch the positions. It's y to the third minus 4. And so now I'm going to move this x over to the other side, and then so that'd be y to the third is equal to x plus 4. And so here, I want to take the third root of both sides, so the third root of y to the third is y. And here we'll just express it as the third root of x plus 4. And that is just about as simple as you can get it. So there's your answer. Right? One more example to look at. So I'm going to take this down, reverse it. And so we will have y is going to change to x. So I got x is equal to the square root of 2y plus 3. Okay, so now on this one, I want to solve for y, right? So that means I need to get y out of this radical. And so actually what I'm going to do is square both sides. So that'd be x squared is equal to, remember square root and squared are opposite operations, so that'll get rid of that square root for us, which is what we want. So I just squared both sides there. I'm trying to solve for y, so I'll move the 3 over to the other side. I got 2y is equal to x squared is over here staying put, minus 3 goes here. And now I'm ready to divide both sides by 2, which means y is going to be equal to x squared. And let me see here. I made a mistake. I'm going to have to switch these signs. Why didn't y'all tell me I made a mistake? That's minus, which means that's plus, and that's plus 3, and over 2, and then so there's your inverse. So when I copied this down, I changed that from minus to plus, so I just went in and corrected that all the way through. And then so there is your inverse. All right, so that does it for that lesson. Your quiz will be waiting for you, and we'll see you in class.